Real quick on the types of solutions you might see. Let's say these are all quadratic equations. Quadratic means what power? X squared, right? Okay, let's say these are all x squared polynomials. Let's say I graph the first one, and this is the graph I get. Okay? Where are the solutions? Wherever it crosses the x-axis. So can you see them both right here? Okay? If you can see both of the solutions on the graph, you know that it has two real solutions. Whatever this number is and whatever that number is. This one would have two real solutions. Because you can see the two distinct spots where it crosses the x-axis. So it has two real solutions. Okay? What if it just comes down and just touches the x-axis at one point and then goes back up? It has one real solution, but it has a multiplicity of two. Okay? And I'll come back to that, but this one will have a multiplicity. One real solution with a multiplicity of two, and I'll show you an example of that in a moment. Okay? How about this guy back over here? It's still an x squared function, but it doesn't cross the x-axis.
No real solution.
No real solutions, which means it has to have two, if it's not real, two imaginary solutions. Okay? So this would have two imaginary solutions. Okay? Or in other words, the two values that would make it equal 0 will both have an I in them. Okay? They will be non-real solutions. They'll be two imaginary solutions. I'll give you an example of each one of these here in just a second. Okay? Let's say my polynomial is x squared plus 6x plus 9. And I ask you to find the solutions to. Okay? Let's find the solutions to x squared plus 6x plus 9. So let's set it equal to 0, then let's solve it. And let's hope we can factor it so I don't have to use that silly quadratic formula. Can I factor this? What is it? X plus 3, x plus 3. What do I do with each factor? Set them equal to 0 and solve, and I get x equals negative 3 and x equals negative 3, right? So it has two solutions, but they're the same number. So this is an example, okay, where if I told you to list the zeros of this polynomial, you would say negative 3 with a multiplicity of 2. Basically, it's saying negative 3 is a 0 twice, which you can see here when you factor it. Which means graphically, the graph looks like this. Right here at negative 3, the parabola comes down, touches it, goes back up. Still has two solutions. It's just negative 3 and negative 3. Negative 3 is a solution twice. Negative 3 would make this equal to 0 if I plugged it into that factor. Negative 3 would make it equal to 0 if I plugged it into that factor. So it has two different places where if I plugged it in, it would equal 0. It has one real with a multiplicity of 2. I don't want you to think it only has one 0. It has two zeros. It just happens to be the same number. Okay? It's one of them, but it has a multiplicity of 2. Only one number with a multiplicity of 2. Have I said it enough ways to make some sense there? I want to make sure it's clear. Because I don't want you to ever think, oh, this only has one solution. No. It may have just one numerical value that is a solution, but it's a solution twice. Because, again, whatever the highest power is, that's how many solutions there are. Does this kind of make some sense how that can happen?
Yeah.
Okay? We'll give you another one within the, I'll do this guy right here. X squared plus 1.
Be negative 1 times.
Okay? I think we all know the parabola looks like that, right? y equals x squared shifted up 1 unit because we've done our transformations. Okay, that never crosses the x-axis, so it has 0 real solutions, so therefore it has to have 2 imaginary solutions. Let's figure out those imaginary solutions. Let's set it equal to 0 and solve. So what am I going to do? Subtract 1, square root, plus or minus I. Whenever you do the square root, make sure you hit plus or minus right in front there, because it's 2 possible numbers that work. And refresh your memory. If you see this, x squared equals 49, and you take the square root of both sides, what are your answers for x? 7 or negative 7, right? Because both 7 and negative 7 would work in that, so you'd write x equals plus or minus 7. Same thing right here, x equals plus or minus I. Okay? This polynomial has 2 solutions. One of them is I, the other one is negative I. You can't see those graphically because we're not graphing on the complex number plane. We're graphing on the real number plane, where these are real x values, these are real y values. Okay? How do I know for sure that these are the correct solutions? Well, let's plug them in. Okay? And here's where we got to refresh our memory on how to do operations with I. Okay? If I plug in I right here, what's I squared equal?
Negative 1.
Negative 1. Good job. Remember I squared equals negative 1 from algebra 2? I squared equals negative 1. So if I plug in I squared is negative 1. What's negative 1 plus 1? 0. It works. Let's plug in negative I. What's negative I times itself?
Negative 1.
I squared, which is?
I. Plus or minus.
I'm plugging in negative I. What's negative I times itself? I squared, which is negative 1, and negative 1 plus 1 is 0. Well, because what's negative I times itself? I squared, right? Negative I times itself is I squared. I times itself is I squared, right? So either way, I can prove that both of these are solutions, because when I plug them in, they satisfy the equation.
I don't know if it's a real number plane or
We'll always graph on the real number plane. We're not going to mess with the complex number plane. Okay? But this would be an example of a quadratic equation that has 2 imaginary solutions. Okay? All right?
So would you want us to write that with I with a multiplicity of 2?
No.
Also, I think I understand everything except the one thing I asked about. So
Okay, all right. I'll shoot you an email if there's something big that I see, okay?
All right, thank you.
Do you see the 2 different solutions here?
Yeah.
This is not one solution with a multiplicity of 2. This is 2 different solutions.
Plus
I is a solution, and negative I is a solution. There are no multiplicities here. Because it's not I with a multiplicity of 2. It's I is a solution, and negative I is a solution. Just like if 5 was a solution, and negative 5 was a solution. Okay, they're different.
And I is always going to be plus.
There always will be a plus or minus, yes. Yep. Okay? Let's say you have a cubic equation that looks like this graphically. What type of solutions will that have? It'll have 3 total because you know it's a cubic equation, right? Okay? Has to have 3 solutions. Do you see 3? No, so that means it only has 1 real, 2 imaginary. Because it's got to have a total of 3, right? Okay? Can a cubic equation ever have 3 imaginary?
No.
No, because the cubic equation is going to have to do what?
Cross the y-axis.
Cross the x-axis somewhere, doesn't it? Because aren't cubic equations like this? Or this? Right? Okay, they got to hit it somewhere. So cubic equations will either have 1 real with 2 imaginary, or it could have all 3 real. Right? Those are the only options. Does that make some sense?
Yeah.
Quartic. meaning has x to the 4th in it. I'm not even going to draw a picture, I'm going to make you think for a second. What type of solutions could a quartic polynomial have? We'll state the obvious one. Could have 4 reals, right? Okay, it could have 4 reals. It might go up, down, like that. Okay, 1, 2, 3, 4. Could have 4 reals. Absolutely. Two real, 2 imaginary. Quartics are going to look potentially like W's in a sense, right? A lot of times. You guys have seen those a little bit. So it might do this, but then the second time it might not come all the way down. So it's got 2 real, and then must be the other 2 must be imaginary then. Does it have to cross the x-axis?
There could be.
Could I slide this W up a whole bunch?
Yeah.
And then would it ever cross the x-axis?
No.
So it could be
0.
0 real with all
Imaginary.
4 imaginary. Okay? Yeah. So you could be 4 real, you could be 2 real, 2 imaginary, you could be 0 real, 4 imaginary.
So the only ones that all have, or that have to have 1 real is like the cubic and
Odd powers. X to the 1st looks like this. Has to cross the x-axis. X squared looks like this. Doesn't have to cross the x-axis. X cubed looks like this. Has to cross the x-axis. X to the 4th either looks like this with a little w or this with, an m, right? Okay? Doesn't have to cross the x-axis. X to the 5th, though, now we're back to here. Has to cross the x-axis. Odd degree polynomials have to have 1 real.
okay.
Even degree polynomials can be all imaginary. Does that make sense graphically?
Yes.
Odd degree polynomials have to have 1 real. Even degree polynomials don't. Imaginaries always have to come in what? Have you noticed it so far? I think you might be right.
Pairs?
Pairs, yeah. They have to come in pairs. Can you ever just have 1 imaginary answer?
No.
If you want a challenge, try and draw something that has 1 imaginary answer. You're not going to have any luck doing it. Okay? Something might have a multiplicity. Imaginary zeros, imaginary roots, this is pretty important. Imaginary roots, imaginary zeros, always come in pairs.
But I thought can't they not have multiplicities then? There's always going to be one.
That's not, they could have multiplicities, but they also might just be what are called conjugates of one another, which I don't quite have time to get into today. They'll always come in pairs. But right now, just write that down. We'll go more into it with the conjugate idea tomorrow.